All right, Danielle, this is Professor Salm, and I'm going to do a screencast quick on how to analyze the information in the spreadsheet that I uploaded on Friday. So when you upload it into SPSS, you can see that there have been a couple columns added here. The type code, which is based on which category of drug. I took the antivirals and made them code 2, the antibiotics broad spectrum code 1, and then I took the type of antibiotic, acyclovir, and gave it a 1, and then went down the list, and I think there are 16 different drugs on the list. So our variable view is important because this is what's going to help us help SPSS do the number crunching, or at least give us our options for number crunching. So we have numeric for PCT, we have numeric for type and drug code, so category and drug name. And then I've also looked at this column, so measure, the type and the measurement. The type is, if it's string, it's only going to be considering it as an alpha sort of, kind of data in that column. If we look at the measurement, it can be either nominal, ordinal, or scale. Scale being if there are decimal points between 1 and 2, so 1.5. Ordinal would be just categorically, so if we have a 1, 2, 3, or 4, just whole numbers, no halves, that would be ordinal. So now I'm going to go ahead and analyze, and you've already deduced how to do the frequencies. You can see here I've got a list of stats that I want to do the frequencies with, and you can say what statistical values you want it to calculate, and then also the charts. Histograms show normal curve distribution, and normalcy is something that we like to know before we do the next step in testing, which is correlation testing. So we'll click OK, and you can see here that you've got the mean, median, mode, standard deviation, minimum. Usually we go with mean as the most accepted in the biological sciences. And then it goes down to give you like charts to break down these frequencies of each of the different columns. Then you've got your histograms with the normalcy curve. Now a normal curve would be a cluster in the central portion of the graph, and here you can see that there are some outline values from the normalcy curve. So this would be, PCT would be non-normal or non-parametric. Drug codes, definitely non-normal here. And then again, non-normal for the type as well. So we've got a non-normal distribution, which means we go forward with non-parametric testing. So I'm going to go under Analyze, and let's do correlations by variate. And all variables that are not string are considered values that we can crunch here. For correlation coefficients, Pearson's is a parametric, or for normally distributed values. We have non-normal distributions, so I'm going to go with Kendall's tau. Spearman would be appropriate if we had the same like 1 through 4 variable for the two columns, but we're going to have zeros, ones, or twos for PCT. The type code is classes 1 through 4 of antimicrobials, and then drug code is 1 through 16 possible drug options. So because these are all different ranges of numbers, we're going to do a Kendall's tau. We're going to do two-tailed because it's possible that PCT monitoring made things worse, not better. If it were just only a possibility of improving, then we would do a one-tailed, but since there's two possible outcomes, we're going to go two-tailed. And the Kendall's tau then shows that when you compare drug code to drug code, it's going to be 1. Usually correlation coefficients fall anywhere between -1 and +1. When they fall closer to +1, between 0.5 and +1, it shows a positive correlation. So you can see here we have a statistically significant to the 0.01 level correlation between the drug code and the drug type, which makes sense, like if amoxicillin is in the broad spectrum, that would be positively correlated. The more we see of one, the more we're going to see of the other. But then we look down here at PCT and how it impacts drug code and drug type, and you can see that the value is falling between 0.5, positive 0.5 and negative 0.5, and that would mean a weak correlation. So it looks like we're seeing a weak correlation between the values of procalcitonin and the drug type and drug code or class. So that, in a nutshell, is the correlation and the sort of descriptive statistics for this for your study. we can sort of talk this over and decide where we want to go, if we want to do any further testing. But this is kind of where we start off. All right. Thanks, Danielle.